Good morning, everyone. Today in this session, I am going to discuss about one more algorithm, that is logistic regression. So we are already in the fourth unit and we are discussing about the classification problem. In the classification problem, we already discussed the two algorithms, that is Bayes theorem and the Navier-Bayes algorithm. And the next one is the logistic regression. So as a name, this regression is not a new word to you. Why? Because we already discussed in the unit 3 what is regression, regression analysis, and different types of regressions we discussed in the unit 3. Now, what is regression? We already discussed regression analysis is a predictive modeling technique, and it estimates the relationship between the dependent and an independent variable, that is target and the predictor. This is all we discussed in the linear regression. Then what is logistic regression? And even though linear regression is there, why developers are preferring this logistic regression? Logistic regression produces results in a binary format and which is used to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical. Hope by this definition you have understood why this logistic regression has come into picture. Linear regression is used to predict the outcome of a continuous variable, continuous dependent variable, whereas this logistic regression is the predict the outcome of a categorical value. And the outcome of this should be discrete or categorical, such as it may be 0 or 1, yes or no, true or false, high and low. Okay. So for this reason, logistic regression is being used. And coming to this logistic regression, it is a supervised machine learning algorithm. Why? Because it comes under classification and mainly used for classification tasks, where the goal is to predict the probability that an instance belonging to a particular given class. Okay, we are going to find out the probability and we are going to set a threshold value. If it is above that threshold value, it belongs to one class. If it is below that particular threshold value, it belongs to the other class. It is used for classification algorithm. Its name is logistic regression. It is referred to as regression because it takes the output of linear regression function as input and uses a sigmoid function to estimate the probability for the given class. Okay. Why the name it has given regression is the input to a logistic regression is linear regression and uses a sigmoid function to estimate the probability for a given class. So the difference between linear and logistic is linear regression output is continuous, and whereas logistic regression is discrete. That is what the difference between linear and logistic regression. Then how does logistic regression work? Suppose, let's say, take an example of this IQ levels. Okay, and when we feed this to a particular model, logistic regression model, we are going to have some threshold value. Suppose we say that if IQ level is above 150, okay, not above 150, we can say let us say 110, greater than or equal to 110. Okay, it is somewhere here wrong. Okay, and then if we have set a threshold values, let's suppose say 100, then whoever IQ levels are having more than 100, then they are going to be selected, and whoever the IQ levels are below 100, those are going to be not selected. In this way, logistic regression works. Okay, let me explain you one more example with how this particular, there is a problem statement. For this problem statement, how a logistic regression model is going to work. Let's imagine you have a car and it's been a few years since you serviced your car. Okay, one day maybe you wonder that maybe the chances that it may break down. Okay, now you want to predict how long until the car break down. As per the years, suppose you have completed 2 years or 3 years, till now your car didn't break down, but you want to predict, okay, after how many years the car may break down. Okay, for that we are going to use and say this is like same linear regression. We are going to have a x-axis and y-axis. Here in x-axis, we are going to give years since service, and in the y-axis, the probability of breakdown. Okay. So here, we are going to give the probability values here. Probability, you know, always it ranges between 0 and 1. And in the x-axis, the number of years. Okay. So the regression model is created based on the others users experience. So for this car might have some people already brought, and you have collected information from them that this is the probability that after this many years the car may break down. With that information, you have drawn a graph. You have plotted the data points here, and this is the graph you have got for a logistic regression. This is also called as a S-square. Okay. Now, already told you, logistic regression, it is a classification algorithm used to predict the binary outcomes for a given set of independent variables. And the dependent variables outcome is discrete. Again, why we are saying independent dependent is it comes under the regression. Regression itself is the shows the statistical relationship between the independent and the dependent variable. Now, we have found the logistic regression and we have set a threshold of 0.5. And see here, this after certain 2.5 years, okay, the probability is less than 0. If it is less than 0.50, the value rounded up to 0. Okay, whatever the threshold value is 0.5, we can round it off to 0 and we can conclude that the car will not break down. That is no. And suppose here it is since 5.5 years, okay. See here, the threshold value indicates that the car is more likely to break down after 3.5 years. See here, 3.5 years, here we have set a threshold. If you cross 3.5 years, chances are there that your car may break down. That is what the conclusion over here. And after 5.5 years, the probability, the value you have got is 0.90. It is greater than 0.50 and it is almost equal to 1. Then definitely the car will break down. Then you are going to give us answer yes. So here yes, here no. That is what the outcome of a logistic regression. That is discrete outcome. The class label will give you either yes or no. So in this way, model is going to make predictions based on the probability value. So simple. Here we have to set some threshold value. If it is greater than the particular threshold value, the outcome is 1. If it is below the threshold value, the outcome is 0. Okay. So to understand this logistic regression, let's talk about odds of success. The one terminology or the math behind this logistic regression is we are going to use odds. So it is represented by theta. That is probability of an event happening divided by probability of an event not happening. That is P divided by 1 minus P. The values of these odds range from 0 to infinity. Odds value ranges from 0 to infinity. The values of probability changes from 0 to 1. We know that the probability is from 0 to 1. Now, let us take the equation of the straight line. We already know, we already discussed in the linear regression. This is the straight line equation and we are going to have intercept and slope B0 and B1. And x is the value of the x coordinate and y is the value of the prediction. And the equation would be, we know that y equal to B0 plus B1 into x. This is the linear regression equation. Okay. Now, coming to the logistic regression, now we predict the odds of success by simply logarithm of this particular value. That is probability of x divided by 1 minus probability of x equal to B0 plus B1 into x. This simple y we are going to replace with a this logarithm of this value. Now, exponentiate both sides. Exponentiate both sides. Okay. That is, see, when you exponentiate of this both sides, the equation will come something like this. Then let solve this one. Let y equal to e to the power b0 plus b1 into x. Then this p of 1 minus px is equal to y. Then probability of x equal to cross multiply this, that is y into 1 minus px. And if you take y inside, you'll get y minus y p of x. And this, the next step, just bring this right hand side to the left hand side. It will minus y of p of x becomes y of plus y p of x equal to y. And if you take p of x as common, we'll get 1 plus y equal to y. And simply the probability of x equal to y divided by 1 plus y. And already we have made y equal to e power
b0 plus b1x. So the equation will become probability of x is become this one. E to the power b0 plus b1 into x and 1 plus e power b0 plus b1x. Okay, so this equation is called as the sigmoid function. Okay, so this is the sigmoid function, the same thing. And one more way how we are going to represent is this. It may be, if you take this one as common, this can also be written as 1 by 1 plus e power minus b0 plus b1 into x. Either of these two, of anything, the sigmoid function can be used for calculating the outcome of a particular logistic regression. See, this is a sigmoid curve is obtained once we have calculated the outcome of a particular variable using the above equation. Okay. See, this one, a sigmoid curve we are going to obtain. Then, how this linear and logistic regression is different. It's very important. So, we know that it is used to solve the regression problems and the response variables are always continuous in nature. And it helps estimate the dependent variable when there is a change in a independent variable. Whenever there is a change in independent variable, definitely there will be a change in dependent variable. That is what the linear regression. And we are going to get it as a straight line. Then, coming to the logistic regression, yes, it is used to solve classification problem. Okay. The response variable is categorical in nature, whereas here continuous in nature, here categorical in nature. It helps calculate the possibility of a particular event taking place. Okay. It is going to help us to calculate the possibility of a particular event is taking place or not. That is P divided by 1 minus P. And it is S curve, where S equal to sigmoid function. So these are some of the difference between linear regression and the logistic regression. The same thing I have represented in a table format. Once you read this, and we'll come to it'll be clear with what is this regression algorithm and the classification algorithm. The same thing. In regression, the output variable must be of continuous nature, whereas here it is a discrete. The task of the regression algorithm is to map input value with the continuous output of variable value. But here the task of the classification algorithm is to map the input value with a discrete output variable 1. Okay. And this regression algorithm uses continuous data and it is discrete data. In regression, we try to find the best fit line, okay, which can predict the output more accurately. And here in classification, we try to find the decision boundary, okay, which can divide the data set into different classes. Here some classes will have, here some classes will have, okay. And the examples like weather prediction, house price prediction comes under regression, whereas here identification of spam emails, speech recognition, identification of a cancer cells, etc. These are all comes under the classification. Okay. And coming to the regression algorithm can be further divided into linear and non-linear regression. Whereas coming to the classification, it can be divided into binary classifier and the multi-class classifier. And coming to these applications of logistic regression, weather prediction. Okay. The very first application, it helps determine the kind of weather that can be expected. And then image categorization identifies the different components that are present in the image and helps categorize them like this. In this particular image, it will categorize these are human beings, these are animals, these are vehicles. Then healthcare. Okay. A particular patient is having any disease or not. Determines the possibility of patient survival, taking age, some ISS and RTS into consideration. That is injury severity score, okay, revised trauma score. Taking all these conditions, we are going to determine the possibility of patient survival. Okay. So these are all, this is what an introduction to this logistic regression and how we are going to the math behind logistic regression. And we have seen the difference between linear and logistic regression. And the last, we are seen the logistic regression applications. And coming to this logistic regression, we also have a week 5 program. Okay. So that we will discuss in the next class with one data set. Let us implement one logistic regression and we'll find the metrics of this particular logistic regression. Thank you.